Hello, grade 12. Today our topic is going to be on forces. I think this is a question 2 in paper 1 physical science. Forces. I think paper 1. A force, there is a traditional definition of a force. I think for a man on the street, a force, we used to say back then, a force is you push or a pull. That's a traditional definition of a force. Back then, force is a push or a pull. That's a very, very simple definition so that a man on the street can understand. If you push something, you apply a force, and if you pull something, you apply a force. But in physical science, grade 12, to put this thing in a proper context, we say force is the mass times acceleration. So that's the definition. Force is the mass times acceleration. You know what a mass is? A mass is measured in kg. Mass of a certain substance, suppose, is 50 kg. Normally your mass is measured in kg. And A is an acceleration. Acceleration is, we define it as a rate of change of velocity. Acceleration is a rate of change of velocity. It's very, very important that your acceleration is determined by your velocity. For an argument's sake, if an object is moving at a constant velocity, say for instance an object moving at a constant velocity. If an object is moving, say, at a constant velocity, your velocity is constant. Say that car is moving at 4 meters per second. This means if you have a velocity versus time. So what is the impact of a constant velocity? Your constant velocity means in physical science your acceleration A is equal to 0, which means when you plot the graph of an acceleration versus time, A versus time, that graph exactly is in there. You have 0. This is exactly here. The graph is here on this line. That is an acceleration versus 0 when the velocity is constant. But when a motion is moving at a uniform velocity, which is what you mean by uniform velocity, it means your velocity is changing by the same amount. Suppose your car moved from 20 to 40 to 60 to 80 to 100 to 120. And then on the side of time, 1, 2, 3. So for a uniform velocity, let's say your velocity is uniform, it means uniform velocity. What do we mean by uniform velocity? It means your velocity is changing by the same amount. That's what it means by uniform velocity. How do you draw this on the graph? That's the way to do it. It's just going like this. That is a velocity versus time for a uniform motion. It means it's going like this. That is, your velocity is changing by the same amount from 20 to 40 to 60. There is a constant 20, 40, 60, 80, 120. That's called that uniform. It's a uniform for motion. Then how do you draw the acceleration versus time graph? Your acceleration versus time graph for a uniform velocity, it means your acceleration is changing by the same amount. If you have an acceleration here, you have a time here, it means now your velocity, your acceleration is maybe your acceleration, let's say for instance, is 4 or 2, let's say it's 4 or 2 here. Let's say acceleration is 2 meters per second. It means now your velocity is increasing by the same amount. That's what it means. That's what I want to try to explain about velocity and acceleration. So let's go back to the forces. You must know the Newton's first law. You must know Newton's second law. You must know Newton's third law. You get a lot of marks by knowing the definitions. Newton's first law, Newton's second law, Newton's third law. You know most in Newton's first law, a body will move from rest or continue to move in a straight line unless an unbalanced force exerts a force on it. The second law is that an acceleration of an object is directly proportional to the force and inversely proportional to the mass. That's also very important. Thus, acceleration is F over m, which is your acceleration will depend on your force. If the more the force is applied, it will have direct impact to the acceleration, but is also inversely proportional to your mass. For example, if you push an object, say for instance you push this object, and this object is 100 kg, and you push another one, say for an argument's sake, is half, is 50 kg. So you push this object, you push this two object. We say acceleration is directly proportional to your force and inversely proportional to the mass. Now the mass is the acceleration. Your mass is big and your mass here is small. So it means now your acceleration will be affected by your mass. Your acceleration will be very low because your mass is big. But now as you decrease the mass, your acceleration is increasing. As the mass increasing, the acceleration decreases. As the mass goes down, your acceleration goes. There is that direct inverse relationship. But between acceleration and force, we talk of a direct relationship. The more the force you apply, the more the acceleration of an object. So that's the background that actually I just want to give you, grade 12 learners. You must know that those terms are very important when you are dealing with physical science. Now let me exactly come to physics, the proper context in terms of the grade 12. May you allow me to erase this. Okay. In pushing the box, let's say you have a box. I will also refer to 50 kg box. You pull that box. You pull that box. You pull that box. You are someone. I don't know how to draw it, but let's say there's a person. Yeah, sorry, you pull that box. You're still going forward. Let's, for instance, they say there is a friction there. We talk of a net force, F net. What do you mean? We talk of F net, which is equal to mass times acceleration. We are referring to how many forces that will be acting. If I pull this table, there is another force that is acting in the opposite of what I'm doing. That force is called a frictional force. It's always in the opposite direction. Say for an argument's sake, if we pull this book to this direction, your friction is in the opposite direction. For example, let's say your frictional force. Oh, sorry, my pen writing is 2 Newton. You pull this 50 kg, and then your frictional force, let's say, is 2 Newton. Then what is your F net? My F net will be the sum of let's say you push this box, you use 20 Newton to pull this box. Then what is my friction force? My friction force, and your friction force is 2 Newton. Then what is the F net? The F net is the sum of the force applied plus the friction force is equal to mass times what? Times an acceleration. But what is my force applied? Let's say is 20 Newton. What is my friction force? It's minus 2 Newton. Let's say is equal to mass times mass. What is my mass? Mass times acceleration. Say for an argument's sake, they say the object is moving at a constant velocity. They say the object is moving at a constant velocity. If the object is moving at a constant velocity, it means the UA is equal to 0, as I told you. If the object is moving at a constant velocity, it has a direct impact on your acceleration, which is A is equal to what? 0. Then that's how you relate all these things, which is the 20 Newton minus 2 Newton, which is equal to mass times acceleration, then you get 0 here. Then that's 18 newtons, which is the direct impact of the force is 18 newtons. I was just giving the example, not relating specifically to the so what I want to say to you is that you must know when you talk of an F net, you are referring to two forces which are acting in the one is acting in other direction, one is acting in the opposite direction. Okay. Say you put this object at an angle now. They say this angle is 30 degrees. Here is the force applied. They say there is this what we call the object here is 20 kg. Then your friction force, they say is 3 Newton. Then they ask you to calculate, and the object is moving at a constant velocity. Let me read over is moving at a constant velocity, which is constant velocity. You must always watch for constant velocity. Is A is equal to what? 0. So how do you move about the whole situation? Then you say your F net is equal to mass times our what? Acceleration. How many forces are acting here? This one is acting at an angle, so we call this one a horizontal component. That is the F cos theta minus the friction force, which is equal to mass times acceleration. Then what is my degree? This is cos 30 degrees. What is my friction? Is 3 Newton. You know the friction also is plus and minus. The friction is always in the opposite direction. Then your acceleration is equal to 0. Then it's a direct impact. Then you get 0. Then I take what is cos 30. Cos 30. I don't know whether it's Roper. I'm not sure about cos 30, but whatever you get, yeah. Then you take cos 30 is equal to 3 Newton. Then my cos 30, let's for instance, I don't know whether it's 0.5 or whatever. I don't know, it's 0.5 whatever. Then 3 Newton. Then F is equal to 3 divided by 0.5. Then you get, is that answer you get. I'm not sure what cos 30 is. So the point is that if you are pulling an object at an angle, you say now is F cos theta plus minus the friction force, which is a minus 3 Newton, is equal to 0. Why you call it 0? Because your acceleration is always 0. Then you take this 3, you go, it becomes 3 Newton. Then F cos theta, you divide. I don't know, cos theta is 0.5, I don't know. Then you take, you divide. Then that's how you will be getting your answer. Grade 12. It happens only if this thing is acting at an angle. Of grade 12. Okay. There are different scenarios that I'm giving you the different scenarios when this force F is applied on an incline, when this force F is applied on the horizontal surface, when this force F is applied at an angle. Then we have what we call kinetic coefficient friction, UK, which is enormous when you're dealing with a friction force. But what I want to explain, they say for instance, all these objects, they say acceleration is 2 meters per second. For all these objects, let's for an argument's sake, they do have the same acceleration. Then I just want how to express the formula for calculating these problems. Here, there is a friction force. You apply this, there is a friction force. Then how many forces that are acting on this object? No, we have got this force applied, we've got a friction force, we've got a force of gravity. Now you are moving at an inclined plane. There are 3 forces that are applied, that you apply on an object. is called friction force, force applied plus the friction force plus Fg, force of gravity, is equal to mass times acceleration. So there are three forces on the that are acting on the particular object: force applied, the friction force, and the force of gravity. Here there are two forces that is the force applied, is the friction force, it's called to mass times acceleration. Also here there are also two forces, but this one you applied at an angle now. But how do you express it? We say it's F cos 30 minus plus minus, you know almost your friction is always a minus, minus the friction is equal to the mass times what? Acceleration. Grade 12 is very important to express, to understand what is really happening. Let me try to explain it again. There is a this force is applied at an angle. Then how many forces that are acting there? There is one, there's force applied, this one, there is a friction force, there is a force of gravity. We already know that when everything is moving away from the surface of the earth, there is another force, cause of gravity, that is applying on that object. But now it is on the horizontal plane. Then the force applied minus the friction force, they say your mg is equal to 0, is on the solar. Then what happens here? Now is F cos 30 plus minus the friction force called mass times acceleration. I was trying to explain different situations. Right. Let me come to this what we call the, let's for in argument's sake, they do have coefficient kinetic, which is 0.2. So how do I express it? Yeah. My friction force, I want to calculate it separate. My friction force is equal to UK normal, but UK is 0.2. But how your normal now? If you have if an object is moving at an incline, your normally is mg cos. Your normally is m. Your normal now is m. Your n now is equal to mg cos 30 degrees. That's what I want to explain. Your normal now is mg cos 30. Mg cos 30, which is what? Instead of writing n, you know, is mg. And what is my mass? Is 20. What is cos 30? Oh, sorry, I don't even know this cos 30. Oh, sorry. 9, my g is 9,8. My cos 30, sorry, I don't have my cos 30 degrees. So what I'm trying to explain is that your kinetic coefficient is 0.2 and your normal now is mg cos 30 degrees. Mg cos 30 degrees. So your friction force is the 0.2 times 20 times 10,8. Then what is my force of gravity? What is my Fg? What is my force of gravity? My force of gravity now is mg sine 30 degrees. That is my force of gravity, is mg sine 30 degrees. So when you come here to that equation, that if I want to calculate this force applied is equal to my friction. What is you multiply all these things. I don't know what to get. You multiply all. You say it's a multiplication. It's plus. It's a multiplication of 0.2 times 20 times 9,8 times cos 30 degrees plus what is my force of gravity? It's mg sine 30. It's mg. What is my mass? What is my mass? Is 20. What is my g? Is 9,8. Sine 30 degrees. That is equal to your mass. If my mass is 20, it is 20 times your acceleration times 2. That's how you can calculate. And then at the end of the day, you combine all, you get your answer, and you take it and you leave my force applied. That's the principle that I want to give you grade Grade 12 students. Now let's come to this situation. How do you calculate the force applied in this scenario? So the force applied, as I told you, there are two forces that are acting there. Is the friction force. Then my force applied now is Fa plus minus the friction is equal to mass times what? Acceleration. Then my force applied. Then how do I calculate this friction force here? My friction force is equal to now UK, can it plus my normal UKN, which is UK. Then my normal is mg. Do you see the difference? When it's going in an inclined surface, is mg, my normal is mg cos 30. But on the horizontal surface, my normal is mg. I think you get an understanding of what I'm saying. On the horizontal surface, my normal is mg. Then it's 0.2. Then it's 20 times 9,8. Then that's my friction force. So in other words, what is your friction? Is going to be a negative. It's going to be the negative 0,2 times 20 times 9,8. What is my mass? My mass is 20. What is my acceleration? We said our acceleration, let's say for an argument's sake, is 2. So they have got the same acceleration. Then you calculate, you get what you want to, what you get. Let's come to this problem. Then I told you it's mg is F cos 30 minus the friction force. I just want, how do I express my friction, my friction force? How do I express my friction? We know that your friction is kinetical times your normal. Then what is my U? Is 0.2. But then what's the difference with my normal now? You said my normal here was mg cos 30, and if this thing is on the horizontal form, my normal is mg. But if you apply that force of an angle, what is the direct impact of your normal? Your normal now, if you pull something at an angle, my normal now is my normal now is mg minus f sine 30 degrees. I so wish to understand. Now you apply the force at an angle. You're pulling this object at an angle. Then what is your normal now? My normal is mg minus f sine 30. If you apply the force at the horizontal, what is your normal? My normal is mg. My normal is mg. If you apply the force on an inclined surface, what is happening to your normal? Your normal is mg cos 30. That's the situation. That's the thing that I want to explain to you, grade 12. I'm not going to calculate. You have your own calculator. You know how to do all this thing. I'm not going to calculate, and you know my space is very small. So a point that I want to raise here is that we have got f cos 30 plus the minus the friction. My friction is kinetic coefficient, which is 0. It's going to be UK, which is UK. Your normal now changes. My n is mg minus f sine 30 degrees is equal to mass times what? Acceleration. Then your f cos 30 degrees, 30 degrees minus, what is my u? Kinetic coefficient is 0.2. What is my mass? mg is 20 times 9,8 minus f sine theta, which is sine theta, I believe is half. Is equal to, what is my mass? My mass is 20 times 2. I'm trying to, grade 12, to look at different situations. Then how to calculate looking at the different situations. When an object is on the incline, when an object is on the horizontal, when an object is really pulling the object at an angle. I think that is all I just want to explain, because I don't want you to be confused. I just want, from now I think I'll try to explain the difference in how your normal changes. That's what I wanted to explain to you. Let me raise this object. Problems that involve tension. Let's say here is an inclined surface. Here is a box. The box is 30 kg. Here is another one. Let's say it's 20 kg. Here is the force applied there. Let's say acceleration again, maybe it's 1 meters per second squared. That's an acceleration. A point, let's say your angle always, let's say, is 30 degrees, but not always 30 degrees. Now they can ask you, oh, sorry, you don't have any cut. Let's say acceleration is an unknown. They say they give you this force, they say it's 20 Newton, okay, let's say it's 50 Newton, okay, it's 60 Newton. That's the force they are applying. Right, you applied 60 Newton on the box of 30 kg. And then there is also 20 Newton. The point I just want to make it, I'm not going to calculate, but I just want to make how to express the whole situation. Right, we have between this 30 kg and this 20 kg there is a tension. There is a tension between 20 kg. Here is a rope. There is a tension now between this. For example, how to express this thing? We have got this force. That is, you applied at an angle. Then that's called force applied, which is 60 Newton. That is force applied on the 30 kg. Let's say the friction force on the 30 kg is, let's say on this, let's say is 2 Newton. On this one is 1,4 Newton. Let's say it's 2 Newton, it's 1,4 Newton. Then how to express how to make the equation for this thing? We have got a force applied, which is, and then you have the force applied plus minus your friction force minus the force of gravity. Minus again the tension. That is equal to mass times acceleration for 30 kg object. What is force applied? It's 60 Newton. But what is my friction? It's minus 2 Newton. What is my force of gravity? It's 30 minus 30 times 9,8 minus tension is called, what is the mass? Is 30. Then your acceleration is known. That's how you express the equation for the 30 kg, because we have got 60 Newton minus 2 Newton minus 30 times 9,5. Then that is called in equation 1. Then for equation 2, for this one, my tension is acting in this direction. For 30 kg, the tension is acting on the opposite direction. It's downward. For 20 kg, the tension is acting on the upward direction. Then I minus the friction 1,4. That is the friction force. I minus the force of gravity, which is 20 times 9,8. That is equal to, no, mass times acceleration is 20 times 8. Then you solve the equation. You cancel this thing, then you can get evaluate acceleration. Simultaneous equation, grade 12. I know you are familiar with this thing. Say it, let me repeat it again. If you are given a situation and you have a tension, you must express the equation for this 30 kg is force applied minus the friction minus the force of gravity minus the tension, because the tension is acting on the direction. For this one, 20 kg, your tension is acting in this direction. In the upward direction. Then is my tension minus the friction, which is 1,4 minus the force of gravity. Then you express is equal to 20. Sorry, it's equal to 20 A. Then for you to get A acceleration now, for you to get to acceleration, which is you cancel this with this one, you solve this equation simultaneous. I think you have been told in your teacher by your teachers how to do this simultaneous equation. So you must be very important when you have a tension. You must know that they will ask you. For you to get acceleration, you must try to solve your tension. You must have 2 equations. That's very, very important. And they always give you 7 marks or 8 marks for doing that. So I think I've already explained this thing. If you have force applied 30 kg and 20 kg, that's why grade 12. I think I'm almost done. I tried to introduce the forces. What's the difference between A and B and C? What's the difference between that one and that one? I think you enjoy your lesson. You keep on calling us. We'll try to explain each and every question. If maybe we've made a mistake, you can call us that there is something that you don't understand. Then we can explain how it is. Yeah. Thank you, my grade 12 2020. And my name is Dumisane Msila.